This is something you'll be seeing later on in the calculus. The average rate of change of a function over an interval. This is equal to the difference quotient, which is the slope of a line through 2 points on a function's graph. So here's a graph of a function. Here it goes through x by f of x. We move over a distance h to x plus h and rises up to here to x plus h by f of x plus h. The slope of this line, that's the difference quotient, equals a change in f, just a moment, change in f of x plus h minus f of x, over the change in x plus h minus x. Now the denominator, the x cancels out, and you get f of x plus h minus f of x over h. That's the difference quotient. That's the average rate of change. It's also denoted delta f over delta x, the change in f divided by the change in x. Now the problems below, the numerator, delta f, is called the net change, how much f changes in all. Then you divide by how much x changes in that same interval, and that's the average rate of change. So for example, here we have a function, goes from 0 by 6 to 5 by 2, it slopes a little bit. What's the net change and what's the average rate of change? Net change is the difference in the y values, 2 minus 6, negative 4. The average rate of change is 2 minus 6 over 5 minus 0. 2 minus 6 over 5 minus 0, that's negative 4/5. So it's sloping downwards like that. Here we have function h of t equals negative t plus 3/2. Find the net change and average rate of change between t equals negative 4 and t equals 1. So you make a table here. When t is negative 4, h of t is 5.5. When t is 1, h of t is 0.5. The net change is the later value of h minus the earlier value. 0.5 minus 5.5 is negative 5. The average rate of change is that negative 5 divided by 1 minus negative 4. So it's negative 5 over 5 is negative 1. Here, delta f and delta f over delta x for f of x equals x cubed minus 4x squared between x equals 0 and x equals 10. So you make a table, set x equal to 0 and 10, calculate f, 0 for x equals 0, 600 for x equals 10. Change in f is 600 minus 0 is 600. Average rate of change is that 600 minus 0 divided by 10 minus 0. Change in f over change in x. That comes up to 60. Here we have delta f and delta f over delta x for f of x equals 3x squared between x equals 2 and x equals 2 plus h. Okay, now we have a variable delta x. Here we go. At 2, f equals 12. At 2 plus h, it's 3 times 2 plus h squared, which when you expand and distribute, you get 12 plus 12h plus 3h squared. Okay, delta f is 12 plus 12h plus 3h squared minus 12. The 12 is canceled, and you're left with 12h plus 3h squared. The average rate of change is this, 12h plus 3h squared divided by 2 plus h minus 2. The 2 is canceled, left with an h, cancels against these, and you get 12 plus 3h. Now I have to admit, we're assuming here that h is not 0. If h were 0, then you get 0 divided by 0, which is an indefinite ratio equal to anything. Here we have g of x equals 1 over x. Find delta g and delta g over delta x for x between 1 and a. All right. When x is 1, g is 1. When x is a, g is 1 over a. So delta g is 1 over a minus 1. We can rewrite as 1 minus a divided by a. Delta g over delta x is 1 minus a over a minus 1. And after we do some cancellation, we're left with negative 1 divided by a. All right, and you'll definitely be seeing these average rates of change later, if and when you get to the calculus. The trick there is that we let delta x approach 0 as we wind up with the slope not between 2 points on a curve, but tangent to the curve. That's for later. Okay, I think we're done.